Hello, this is Randy Mercurio, the ICP Technical Specialist at Glass Expansion. In this presentation, we will explore Glass Expansion's Peltier-cooled cyclonic spray chamber kit, or PCC kit, and review an actual customer success story about how they improved their washout and efficiency with an example of a high boron sample on an Agilent ICP-MS. One of the major challenges an ICP laboratory faces is the excessive washout time required from methods analyzing samples containing high levels of elements, such as boron and mercury, that tend to stick around in the sample introduction system. These sticky elements frequently require multiple rinse blanks following these samples to flush the system back down to reporting limits, and in some cases down to method or even instrument detection limits. If there is an inadequate amount of rinse time, these high concentration samples can frequently require a lab to rerun or flag samples analyzed after a sample containing high levels of elements like boron. In this webinar, we will review the design of Glass Expansion's high-performance Peltier-cooled cyclonic spray chamber, or PCC kit. We will explore the efficient and rapid washout of boron from the sample introduction system of an Agilent 7900 ICP-MS using the PCC kit. Specifically, we will evaluate washout data collected using a real-world sample containing greater than 4 parts per million of boron to compare the washout efficiency of the Scott-style spray chamber versus the PCC kit at a high-throughput environmental laboratory. This presentation is based on the Glass Expansion application note, Rapid Washout of Boron using Glass Expansion's Peltier-cooled cyclonic spray chamber on Agilent 7900 ICP-MS, which is available on our website, and it can be downloaded by scanning the QR code. The PCC kit enables the switch from a standard Scott-style spray chamber to Glass Expansion's Tracy cyclonic spray chamber. Here are some of the key advantages of the PCC kit spray chamber. The primary advantage is being able to use Glass Expansion's cyclonic spray chamber design along with the Helix CT or constant torque nebulizer interface, which minimizes washout time, optimizes nebulizer sensitivity, and ensures consistent day-to-day performance. The second advantage is the ability to swap spray chamber material types for different analysis demands. For example, one day you analyze routine samples that can operate using the standard borosilicate glass spray chamber, and perhaps the next day you need to perform an analysis with hydrofluoric acid, so you can swap the glass spray chamber with a PFA one. And maybe you get a special project requiring low-level boron analysis, and you can simply install the quartz spray chamber to obtain the best detection limits. This versatile spray chamber system can handle nearly any type of analysis within a few minutes of component swapping. The third advantage is that the PCC kit comes with everything you need to swiftly install it and seamlessly integrates with your existing communication port, water cooling system, and software. The fourth advantage is that the Jet Vortex interface, or JVI, enables you to use your current method settings for makeup gas and dilution option gas. There are three main PCC kit types. The first one on the left is compatible with the Agilent 7850, 7900, and 8900 when Agilent's Advanced Valve System, or AVS, isn't being used. The one in the middle is compatible with the Agilent 7850, 7900, and 8900. However, it is specifically designed to be used with Agilent's AVS, which I will show more about shortly. And the one on the right is compatible with the Agilent 7700, 7800, and 8800. All of these PCC kits can accommodate glass, quartz, or PFA spray chambers. The PCC kits on the left and right are also compatible with other OEM switching valves. The picture here shows the quartz PCC kit installed with the AVS on an Agilent 7900. It is also compatible when using the Advanced Dilution System, or ADS. Notice how short the sample path is from the valve to the nebulizer. Compared to the standard Scott-style spray chamber, the PCC kit minimizes washout time of highly concentrated samples containing troublesome elements such as boron, mercury, antimony, and even lead. A specialty chemical manufacturer in the US analyzing samples with significant boron was able to use the PCC kit to increase their sample throughput by about 50% when they reduced the number of rinse blanks needed to 1 or 2 from 4 or more. The main purpose of the JVI is to provide highly efficient aerosol filtration by utilizing the makeup or dilution option gas method settings. The JVI connects the spray chamber and a transfer tube and also provides a secure connection to the makeup or dilution gas supply ports using an easy-to-install gas line. In addition, some added bonuses the JVI provides are improved life of torch and interface cones, reduced buildup on injector and cones, all while creating more robust plasma conditions. In this picture, we have a quartz PCC kit set up on a 7850 without the AVS. But in this case, because they were analyzing high matrix samples, it was necessary to employ our Allegra argon humidifier to prevent salt buildup on the nebulizer and injector. This dual channel Allegra is able to humidify 2 lines, and here it is humidifying the nebulizer and JVI gas supplies. This not only reduces salt buildup on the nebulizer, injector, and interface cones, but it also improves long-term stability, which facilitates long, uninterrupted analysis times. The Allegra humidifier is also compatible with the Scott-style spray chamber, and there is an optional magnetic base to mount and support the Allegra on the side of the instrument. You can learn more about this performance optimization accessory by scanning this QR code to see the Allegra flyer. The standard nebulizer used with the Agilent ICP-MS is Glass Expansion's Micromist, which is calibrated for use with UHMI to provide high transport efficiency and can handle up to 15% total dissolved solids. The C-Spray nebulizer will provide the best overall performance with greater sensitivity for many sample types and can handle up to 20% total dissolved solids. If you analyze samples containing greater than 20% total dissolved solids, or if they contain up to about 5% HF, you can use our DuraMist. For samples with greater than 5% HF or high purity analyses, the Opal Mist will be the best choice, and it can handle up to 15% total dissolved solids. Now I'd like to share with you a customer success story. A high-throughput environmental laboratory analyzing particularly difficult samples with high boron concentrations was looking for a solution to their excessive rinse-out times to ensure quality data and improve their sample throughput. The lab was using an Agilent 7900 ICP-MS with the standard Scott-style spray chamber, ISIS 3 switching valve, and SPS4 autosampler. Standard Agilent performance reports were analyzed after instruments were warmed up for thermal stability of the interface. This lab was operating under EPA methods 200.8 and 6020, so each day after the instrument performance reports were analyzed, they also analyzed an EPA tune check report for hydrogen and helium modes to ensure the operating conditions of the nebulizer and JVI gas flows met these method criteria, which are different from the instrument performance reports. A challenging real-world aqueous sample from a remediation site containing 4.3 ppm of boron was used to collect washout analysis data, comparing the Scott and PCC kit by running 10 consecutive rinse blanks after the sample was analyzed. This table represents the averages of 15 instrument performance reports while using the PCC kit, illustrating some key metrics such as the nebulizer gas flow setting, oxides, double charge, and sensitivity, and RSDs for 1 ppb of lithium, yttrium, and thallium. The nebulizer gas flow averaged 1.04 liters per minute. Note that the JVI and collision reaction gases are not turned on at this stage, as this is only an instrument performance check. RSDs are all less than 2.5%, and the oxides and double charge are within the limits. This table illustrates the average of 16 method performance reports in hydrogen mode. The nebulizer gas flow is now set to 0.85 liters per minute, and the JVI gas flow is set at 0.15 liters per minute, while the hydrogen gas has a flow rate of 3.5 mils per minute. Low to high mass isotopes demonstrated good sensitivity, with many RSDs less than 1%. This table shows the average of 16 method performance reports in helium mode. The Neb and JVI settings remain the same, and the helium gas flow is now set at 4.5 mils per minute. Low to high mass isotopes demonstrated good sensitivity and stability, with most RSDs less than 2%. In this data table on the right is the Scott-style spray chamber running the 4.3 ppm boron remediation site sample, which was followed by 10 rinse blanks. This was typically necessary for this lab to be able to get back down below their reporting limit of 10 ppb, and took about 31 minutes. On the left is the PCC Kit data running the same real-world sample, also followed by 10 rinse blanks. However, here you'll notice that the PCC Kit was able to get back down below the reporting limit of 10 ppb after 4 rinse blanks. The same data is graphed on the right. This example demonstrates a significant 61% reduction in boron washout time, which resulted in a much higher sample throughput and decreased the potential for any carryover. To summarize the PCC Kit benefits, compared to the Scott-style spray chamber, the PCC Kit significantly reduces washout times for sticky elements, generating faster washout times. Rapid and thorough washout creates more efficient workflow by lessening the chances of poor RSDs, reducing any necessary sample reruns caused by unanticipated carryover. Reduced memory effects lead to more consistent and accurate data with less analytical drift and longer analysis times. This is especially true when combining the PCC Kit with the Allegra argon humidifier for high TDS samples. The reduced carryover and increased stability with the PCC Kit will generate higher quality data with less flags on blanks, duplicates, dilutions, and even other QA/QC samples. The faster uptake and washout times result in shorter total sample acquisition times, thereby increasing sample throughput. If you would like a free consultation on your current sample introduction system, please contact your nearest glass expansion office by email. We are happy to help you optimize your sample introduction components, identifying performance-enhancing accessories for your ICP, discuss any sample introduction challenges you might be facing, explore ways to reduce operating costs, or perhaps you have a similar situation as this lab did and want to get a PCC Kit quote for your instrument and application. Thank you so much for watching this PCC Kit presentation, and I hope you found this webinar valuable and insightful. I'm Randy Mercurio, the ICP Technical Specialist for Glass Expansion's Americas office. If you are located in the Americas, you can reach our office at geusa@geicp.com. If you are located in Europe, Africa, or Asia Pacific regions, please reach out to those offices directly for assistance. Glass Expansion looks forward to hearing from you in the near future to see how we can help you achieve optimized performance for your ICP OES and ICP-MS systems. Thank you again, and we'll see you on the next one.